So they're asking for the shift of this graph. And if we look at this question, we can see that we do have a shift. That shift is going to occur right here. And remember, when something is in parentheses, that's actually a shift to the left or to the right. And we go in the opposite direction of the sign, so that means that we would be shifting pi over 3. And it looks like we would go to the right because there's a plus, but we actually go in the opposite direction of the sign. So pi over 3 to the left, which is choice, oops, can't spell, which is choice 2. So this question kind of has a lot going on here. First, I want to start by trying to find an equation. So they tell you that the equation is going to be P of t. And they tell you that your start amount is 5. So remember, that always goes to the right of the equal sign. And then we're going to be doubling. So we would be multiplying by 2. Now this is where it gets a little bit tricky. We're in terms of weeks here. So our time is going to be weeks. Now we're doubling every 4 weeks. So let's just say, for example, let's just pretend that the time was 12 weeks. So if we're doubling every 4 weeks, then what I would do is I would divide this amount by 4 to give me how many intervals of 4 weeks we have, which would be 3 intervals of 4 weeks, which would give us a total of 12 weeks. Okay, so again, I'm dividing by 4 so that I can figure out how many intervals of 4 weeks we have. So then when I go over to the equation, I'm going to take that unit, which is t, and I'm going to divide by 4. So that's the equation that I want to use. Now, if you read the question, it says about how many rabbits will there be in 98 days? Well, we can't use 98 days because that's not in weeks. So what I'm going to do is I'm going to take that 98 days and I'm going to divide that by 7 because there's 7 days in a week. And I figure out that that is 14 weeks. Okay? So now I'm going to take this equation over here and I'm going to do 5 times 2, and I'm just going to simply put the 14 in there for my t. And then the rest I can just work out in my calculator, and when I do that, I will get 56.5685, which is choice 1. So we need to factor completely. So I notice that there's a common factor, a GCF, of m, so I'm going to take that out, and I'm going to get m to the 4th plus m squared minus 6. Now, if I look here at what's left inside the parentheses, I can do my AM method. So what adds to 1 and multiplies to negative 6. So I'm going to bring down this m here. And because my coefficient, my highest power right here is a 4, I'm going to split my parentheses into m squared and m squared, because those two together, when I multiply them, is m to the 4th. Now, I need to figure out what multiplies to negative 6 and adds to a positive 1. So that would be a positive 3 and a negative 2. And if we look, these two numbers here, they do add to positive 1 rather, and they multiply to negative 6. And if we look, that is choice 4. So this question is very easy peasy. If you remember one little thing that we did speak about, we have a Pythagorean identity, and that Pythagorean identity, if you recall, is sine squared a plus cosine squared a equals 1. So what you need to just see, and it's very simple, notice this number here, or letter in this case, and this letter here are the same letter. Well, these letters represent the same exact number. So if we go back up to the original question, if this is a 32, then this m also has to be a 32, because they need to represent the same exact thing. Okay, so that would be 32 degrees, which is choice 1. Looking at the graph that they give you in number 5, you can see that g of x represents a parabola. And normally when we start with just a regular parabola, where, let me just draw you a quick sketch, where our vertex is right here at the origin, the equation would be x squared, right? Well, you basically have the same thing. The thing is if I were to draw that picture that they gave you, you are just shifted over, aren't you? And you're shifted over, if you look at it, you're shifted to the right too. So we can take this equation here and we can write that real g of x equation that was given to us in the graph anyway, would be, remember when we shift to the right, we change the sign, put it in parentheses. So that's the equation of the g of x. So my suggestion would be, in your y1, just put in your g of x equation, which we have right here. I'm going to just box it off in red. Okay, so that's what you're going to put in your y1. It's going right there. And then in your y2, you can put the equation of the line that they gave you, which is the 3x minus 2. And then just see where they intersect. Now you can do one of two things. You can do second calc intersect, or if you go to your table, scroll down, and find the x values where both the y values will be the same. And when you do that, you're going to get 1, 1. And you're going to have another point, which would be 6, 16. I think that's a little bit easier to see on the table, not so easy to see on the graph. So these are your answers, which is choice 4. So number 6 is asking which statement is false. That would be choice 3. Observational studies can determine cause and effect relationships. That's untrue. The only thing that can determine cause and effect relationships would be experiments. So choice 3 is the statement that is false. I would start by seeing that I have the same base in both the numerator and the denominator. They're both m's. So I know that what I can do then is take their exponents, which are the 2 and the 1/3, and subtract them. So remember, we keep the base, and then we subtract the exponents, which is 2 minus 1/3. Okay, and don't forget that that is raised to the negative 1/2 power. All right, so then I'm going to subtract those, and when I do that, I'm going to get 5/3. So I'm going to get m to the 5/3 power, and then remember that whole thing is raised, whoops, let's make that a 2, to the negative 1/2 power. Now also then, remember that when we have something like that, we have a power to a power, we multiply. So then that will be equal to m to the negative 5/6. Because what I'm doing is I'm just taking these two powers right here and I am multiplying them. Okay? All right. So I have m to the negative 5/6 power. Now that's not a choice, so I'm going to go one step further and I'm going to do power over root. Now also remember, though, I have a negative exponent. So I can make that exponent positive by bringing m to the negative 5/6, oops, down to the bottom. And let me just undo that one little part here, and that will become m to the positive 5/6. There we go. That's still not there. Now I'm going to do power over root. So the root will be 6, and the power will be 5. And that is there. That is choice 2. So this one is good old-fashioned circle the base, run the race. So remember, we circle the base, we run the race, so we cross the finish line there. And then what we have is 3 to the y equals x. So all we just did was we took the equation that was in log form out of log form. Now they want the inverse. So when we find the inverse, remember, all we're going to do is we're going to switch the x and the y. So that's going to be 3 to the x equals y. And that, if you look at the 4 choices, is choice 3. So number 9 is a pretty wordy question. I would like you to look at the second sentence, and it says, he observed that the average weight of the tomatoes from tomato plants grown in black plastic mulch was 5 ounces greater than those from the plants planted without mulch. So 5 ounces greater. If you look at that dot plot that you have there, and there's a whole bunch of dots all over the place, but in the middle here was 0, and then here was 10. Well, it says that the ones grown in plastic mulch was 5 ounces greater. Well, 5 is in here. And that's certainly well within the 95% confidence interval. We don't know exactly what that 95% confidence interval is, but if you look at the dot plot, mine obviously is horrible, but look at the dot plot on your paper. That 5 ounces is really close to the mean, so that's within that 95% confidence interval. So that being the case, if you look at choice 2 is going to be your answer, by the way, because it says there was an effect observed that could be due to random assignment. When you're within that 95% confidence interval, it could be due to random assignment. It's likely to happen a good part of the time. It's once you're outside that 95% confidence interval where it's statistically significant or very odd or doesn't happen often, that sort of thing. Or like if you were rolling a die, if you're outside that 95% confidence interval, then your die is probably not a fair die. Okay, so that would be choice 2. If you look at the two given equations, you can see that both the b is to the x power and the d is to the x power. So when they're asking you to multiply p of x times r of x, my thought then would be to keep the a and the c outside, and then you're going to have b to the x and d to the x. Now, if you look at what I just wrote, it's really the same thing as what we have originally if we were just to multiply those two together. But I just sort of factored out, so to speak, the constant a and the constant c. Now, that doesn't match any of the multiple choice answers, but if we go just a step further, what you'll notice is if I write b and d on the inside and that exponent x on the outside, another way that we can kind of look at this is, remember, if we have a power on the outside, that means everything on the inside of the parentheses is being raised to that power. So let me go backwards. So that means that would be b to the x, and then that would also be d to the x. Okay? So then, just let me rewrite this again so you can see if I factor out the constants, I can rewrite the bases that are raised to the x power together with that exponent on the outside. And that is choice 3. So I notice that there's a common factor of 3. So let me go ahead and take that out, and I'm going to be left with 6x squared minus 8x plus 29. That equals 0. Now, it's not necessary to take that 3 out, but it does make life a little bit easier when you're going through the quadratic formula. And I am going to go through the quadratic formula because if I look at the 4 choices that I have, all of them kind of have this similar setup to the quadratic formula. All right, so notice, and I'm going to write it over here, that A is 6, B is -8, and C is 29. All right, so let's go ahead and put that into the quadratic formula. So I'm going to get x equals -b, which is going to be +8, because we're negating the -8, plus or minus, and it's b squared, so that's -8 squared, which is +64, minus 4 times a, which is 6, and c, which is 29. And that whole thing is over 2 times a, which is going to be 12. All right, so now I'm just going to simplify what's underneath that square root, and what I'm going to end up with underneath that square root is 64 minus, and when I multiply those 3 numbers, I get 696, and that whole thing is over 12. So I'm going to take a little detour here, and that's going to end up being -632, which clearly is an imaginary number. All right, so I'm going to pull that negative out and make that an I, and then I'm going to break 632 down, and that breaks down to 4 and 150, I can't fit it. Okay, hold on. I'm going to put it up here. 4 and 158. There we go. Sorry about the ugliness of that. So then I'm going to get x equals 8 plus or minus. Now here we go. So if I go down at the end there and I look, I see that the square root of 4 right there is going to be a 2. So then that means I'm going to get 2i on the outside and the radical 158 underneath. And this whole thing is divided by 12. Okay, well, I know that I can simplify. I can see that I have a common factor there. So I can divide everything here, here, and here by 2. So if I divide by 2, then I am going to get a 4 here. I'm going to get a 1 here, and I'm going to get a 6 there, right? All right. And let's see. So if I keep going, that is going to give me 4 plus or minus I radical 58, 158, sorry. Let's make that look like an 8, all over 6. All right, now that still doesn't match any of the answers that I have, but I am getting pretty darn close. I'm going to go an extra step. So what I'm going to do is I'm going to split this up because it does not say a plus bi form, but I notice that all my answers are in a plus bi form. So I'm going to start by looking at this, and that's 4 over 6. And when I reduce 4 over 6, that's going to give me 2/3. Okay? And then my plus or minus sign. Now, if I look at the second part here, actually, let me just maybe pick a different color here. And let's look at that part right there. Now that really can't be reduced, but I can split that up, and that would be 1/6 I. Okay, 1/6 I, and then the square root of 158. And if you look at that, that is choice 4. And there we go. So I would start by putting the g of x equation and the h of x equation in your y1 and your y2. So maybe you want to pause me, stop, and do that. Now, this is what I got, though, when I put that into the g of x went in my y1 and the h of x went in my y2. And I did a zoom 4. So I can see here that I definitely have a point of intersection here, but that's really not a wonderful graph. So then I decided to play with my window a little bit. So what I wanted to do was I wanted to play with that window just a little bit to see if I could kind of zoom in a little bit more. And oops, if you look over here, you can kind of see that that is the intersection point that I'm going to circle right there. And there's a little tail right here from that log equation. You can see right there. Okay, there's a little tail there that shows that intersection a little bit better. Now, let me just erase that so that you can see. Now, just FYI, if you want to know how I zoomed in, what I did was I went to my window and I made my x, I'm just going to put it in brackets, I made my x min a -2 and I made my x max a +2. Now, you can pause me and stop and try this. Okay, then for my y, for my min, I did, 0, and my max, I did 5. Okay, so again, that just gives me a better picture. It's up to you. Then all I did was I did second calc intersect. So when I do second calc intersect, I got, and I'm just going to write it over here, I got -0.9269, comma, 1.8637. And when you round that, you will see that it most closely resembles choice 2. So when I look at the graph of number 13, I kind of look at it and I say, well, that looks exponential to me. So if I look at choice 1, it can't be, because choice 1 is linear, like a line, and that's clearly not a line. So I would cross out choice 1. And then when I go to choice 4, that's showing that, or that's saying rather, that the graph would look like a sine curve, and well, that doesn't look like a sine curve to me either. So I'm down to choice 2 and I'm down to choice 3 because both of those or exponential equations rather. All right, so let's look at choice 2 here on the left. So what I did was I just picked a number that I kind of knew what the y value was. So for example, if I look at x equals 40, so if you look at the graph, x equals 40 there, I would tend to say that the y value that would go along with that would be about 5, maybe a little bit higher than that, but somewhere around there. So what I would do then is I would just take the equation and write y equals 1.04 times 1.43, and then let's raise that to the 40th power. Okay, versus over here I'm going to do the same exact thing. So y equals 1.43 times 1.04 to the 40th power. And work both of these out and just see which one is kind of about 5-ish. Well, when I do the one on the left, which is choice 2, I get 1.7 times 10 to the 6th, which is a very large number. It is certainly not 5. So we now know obviously the answer is choice 3, but let's just go ahead and do this anyway. So when I do 1.04 to the 40, oops, that looks like a 46, I'm sorry, to the 40th power, and then I multiply it by 1.43, I end up getting 6.8655, which seems to match up with the graph pretty closely if you look at it. Okay, so when x is equal to 40, my y value is 6.8655, which is close to what you see in that graph. So the answer is choice 3. So let's work our way backwards. Let's look at choice 2. Now, if I look at choice 2, this is a little bit different because I'm going from a positive to a negative, and then a negative to a positive. Okay, well, I can't be adding every single time if I'm going from a positive to a negative and then a negative to a positive. And we did discuss that when the signs alternate that it is going to be a geometric. So I'm going to kind of do the same thing. So I'm going to take that middle term, which is the negative 80, and I'm going to divide it by the first term that I have. Okay, it's not really a sub 1, but the first term that they were giving me. And when I do that, I get negative 1.25. So if I multiply 64 times negative 1.25 and check it in your calculator, you do indeed get negative 80. Now I'm going to take negative 80 and I'm going to multiply that by negative 1.25, and I in fact do get 100. So therefore we've got another geometric series where a sub 9 can be negative 80, so therefore that is not the answer. So it's got to be choice 1, obviously, and that's one of the reasons why I went backwards, but I wanted you to see the other reasons why the other choices were not the correct answer. Now, with this one, though, just to show you, I can clearly see if I'm going from positive to negative, which I am right here, and then going from negative to positive, it's got to be geometric. So I would do what I did in choice 2 here, and I would do negative 82, and I would divide that by 64. Now, when I do that, I end up getting negative 1.2813. Okay, so I should be multiplying by negative 1.2813. However, if I multiply negative 82 times negative 1.2813, I do not get 100. Okay, what I end up actually getting is like 105.06, so on and so on and so on, which is not 100. So therefore, this will be what the 9th term cannot be. So that would be choice 1. Okay, so I'm actually going to start this problem with going backwards and trying choice 4, then choice 3, then choice 2, then choice 1. And there's several reasons why, but they're giving you the 8th term and the 10th term. And basically, it says if the sequence is either arithmetic or geometric, in other words, it can be either one, what would the ninth term, I'm going to try to figure out what the ninth term could be. And if it makes sense, then we know that's not the answer because the actual question's asking for which one can't it be. So look, I think choice 4 is just the easiest to start with for you to understand this kind of question. So I'm going to look at this and I'm going to say, well, let's see if I'm adding by the same number each time, because if I am, then I know it's arithmetic. And so if I look at choice 4 here, I can see that I actually am. If I do 82 minus 64, I get 18. And if I do 100 minus 82, I also get 18. So what this is telling me is to get from a sub 8 to a sub 9, I'm adding 18. And to get from a sub 9 to a sub 10, I'm adding 18. So that's telling me that this series is arithmetic. So, that being the case, they're asking what the ninth term cannot be. In this case, it does work. So therefore, a sub 9 can be 82. So this would not be a choice. Now, if I know that choice 4 is arithmetic, and I look at choice 3, obviously to get from 64 to 80, or to get from 80 to 100, I wouldn't be adding by the same thing every single time, because then that would just give me choice 4 instead of choice 3. So I'm going to try and see maybe if there's a number that I can multiply by. So remember, the way that we can do this is by taking the second term in the series that we have, which is the 80, and divide it by the first term. And when I do that, I get 1.25. So my guess is that if I multiply 64 times 1.25, I will get 80, which I do. Then what I'm going to try is doing 80 and multiply that by 1.25 and see if I end up getting 100, which I do. So therefore, I know if I'm multiplying by the same term every single time, that makes the series geometric. All right, so then in other words, 80 can be a sub 9, and they want to know which one can't. So I'm going to cross off choice 3 as well.